Hi everyone. So today I'm going to talk to you about this question that I had. How to design good software. So what helped me answer this question last year, right before I was starting my first full-time software engineering job, was this book titled The Philosophy of Software Design. And I think it really opened my eyes and answered a lot of questions that I had. So before we dive into what the book tells us, I think it's useful to first think about for ourselves, like how do you know if software is designing well? I'm sure we have, as software engineers or as CS students, I'm sure we have the experience of sometimes diving into a new code base and thinking, this, and just having this feeling that this code base is not really designed that well. But sometimes when we dive into a new code base, like for me, it was, let's say, PyTorch. I really felt that PyTorch was designed, something like PyTorch was designed really well. But how do we actually quantify or give a framework to describe how well a software is designed? So before we here's an overview of what we'll talk about today. So first of all, the book defines an objective of software design, which is to reduce complexity. Next, we'll talk about what is complexity, what causes complexity, and lastly, how to reduce complexity. So as we mentioned, according to the book, the main problem with software design, the main objective of software design, the main problem with software systems is the complexity of software systems. So how complexity is defined by the author is, complexity is anything related to the structure of a software system that makes it hard to understand and modify the system. So it's not about how complicated the features, like the complicated the software software features or like the code is. It's more about how difficult it is for programmers to keep things in their mind, how difficult it is for a new programmer to dive in and just get started making changes. And I think according to the author, if a software is complicated, it's hard for programmers to keep all things in their minds, and this results in slowdowns in development and buggy code. Therefore, the objective of designing software is to reduce complexity in the design. So how do we know? Let me move this. So how do we know when a piece of software is complicated? So here are some symptoms. The first symptom is change amplification. So it's just a fancy way of saying sometimes, like when we want to change a variable value, how many places requires code modifications for just one simple change, right? Like many times, let's say we forgot to assign a variable to a particular constant. If we want to change the constant value, we have to change it at more than one place, right? Something like that. Second of all is cognitive load. How much does a developer need to know to complete the task? Last of all is unknown unknowns, where this is like the worst symptom, where it's unknown. It's not clear which piece of code must be modified to complete the task. So here's an example to showcase the symptoms. Let's look at the C column here. So in C, we have a constant called banner BG or banner background, which is red, right? So it's used in different pieces in different modules in the code base, in the code. Like say it's used here, BG equals to banner BG, blah 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 blah, and there is another variable called emphasis, where it's assigned to be dark red. So from the first glance, there could be some there's some obvious issues here. First of all, when we make changes to banner BG, we need to know that it's being reused, referenced in this 4 or more places here. Therefore, the developer needs to be cognizant, needs to hold all these 4 modules, 4 downstream modules in mind whenever he makes changes to banner BG. What's worse is there is an unknown of the emphasis variable. Let's say the developer doesn't know about this emphasis variable and he changes the banner BG from red to blue, but forgets to change the emphasis variable from dark red to dark blue. This will be a huge problem and it will lead to bugs. Yeah, so like what the book says, if the background color changes, the emphasis color must also change. But this is not clear when someone looks at the banner BG variable definition as it is. So what causes complexity? Right? Now that we know what complexity looks like, what causes it? So the book gives 2 underlying factors. First of all is dependencies. So dependencies is defined exists when a piece of code can't be understood and modified in isolation. Right. Next of all, the next factor is obscurity, where important information about code is not made obvious. For example, if you use an ambiguous variable name like X or like time, right? It's not clear what this variable name actually aims to do. Second example would be having to change error handlers when error code changes. So for an example, I have a function that throws an error code throws an error code whenever there's an error raised. If I change this error code, I need to know that I like the upstream code, the upstream functions that uses this function needs to know that, hey, now the error code that this guy throws is changed and I need to handle it in a different way. But it's not obvious, it's not a guarantee that whenever I change this downstream function module's error code, the upstream functions must change. Right? It's not guaranteed. It's not obvious to the developer that only looks at the downstream function. Yeah. So now that we know what complexity is and what causes complexity, how do we manage complexity, right? So according to like what we learned in software engineering 101, we learn how to do modular design. So what's the goal of doing modular design? According to the book, it's to provide abstractions, right? Which is like how I think of it as hiding information through encapsulation. Also, we want to minimize dependencies between modules. So examples of modules include classes, functions, files, services, and whatnot. Yeah, so according to the definition from a book, each module consists of A, an interface, and B, an implementation. So let's take the example of a function. For a function, the interface would be the function signature, like the function arguments, the function argument types, the return value, and whatnot. The implementation would be the actual the meat of the code that's abstracted away by the function, like what's inside the function itself, right? So how I think of it is interface is the complexity that the external system sees, whereas implementation is a complexity that's hidden within the module. Yeah. So intuitively, with modular design, if we want to reduce the complexity of an overall software system, we want to maximize the depth of our modules that we design. So according to the book, the best modules are modules that provide the most functionality, yet have simple interfaces. And that's actually quite intuitive, right? Like say, we want to hide as much information, hide as much complexity within our modules, and expose as little complexity through our interfaces as possible. And doing this will guarantee that the overall system has minimal amount of complexity. which according to the book is the main objective of good software design. Yeah. Okay. Let's go next. Yeah. So why deep modules? Like we talked about, more functionality with more simple interfaces minimizes complexity on the system while hiding information in the module. Many aspects of this module can be changed without affecting other modules. Okay, let me move this. Yeah, so I think here, consider like a shallow function, a shallow module like this one. This is bad according to the book, according to this framework, because it offers little abstraction. It encapsulates little information within the module, and the benefits of this encapsulation is offset by the complexity of the interface. It's just as good as doing nothing. I think this also makes me think of like one of my first few software coding classes in college, where I was taught to design software or like write code that's modular, and what I took away from it was just to make functions as often as you can. And at the start, it seems reasonable that every function is that every piece of module is short, right? It looks good, it's easy to understand. But as I started to get more mature as a programmer, when I started to design more large scale software, I find it harder and harder to debug when I have a system like a system composed of small little functions. It's very often easier to debug when all the functions are clumped together into merged together into one big function. It's much easier to debug because I don't have to look around to see where the bug is. I don't have to look around to reference it's in this function, it's in this line, right? So I had this nagging thought at the back of my head for a long time, like, hey, why did school teach me this, but I feel like I feel the other way is more efficient for debugging. And I think this book really answers or clarifies this conflict that I had, right? Yeah. Go. Yeah. So consider a shallow module like this piece of code in Java, right? So this piece of code is trying to read a file from through a file stream, and to implement this reading of file functionality, the developer needs to know three interfaces, meaning three class instantiation signatures. But according to the book, the Java developer might argue that this is useful because it gives the developer the option to use the choice to use a buffer or not, right? According to the second line here. But according to the book, I think this is also another one of my big takeaways, is providing choice is good, but interfaces should be designed to make the common case as simple as possible, right? So we should optimize our design. So my takeaway is we should optimize our design according to the most common case of our most common scenario of our module that our module will be used in. Right. So in this case, most likely developers would prefer to use a buffer when reading a file. They're not using a buffer. So it would be better to wrap all these three modules like file stream, buffer stream, and object stream into one, and provide an option or a toggle in the input arguments to disable buffering. Yeah, then that will be much simpler to implement, and also provides the option. Okay, move. Yeah, so what we talk about. So how should we? So now we know that we want to design deep modules. How do we do it, right? So we want to try to maximize as much information encapsulated within the module as possible. And what the book argues is when we do so, we also simplify. At the same time we also simplify the interface. Why is that the case, right? Because the book argues that when we try to design deeper modules, or like modules with more meat inside, the module itself becomes more general, and this results in this often results in a simpler interface. So how do we do it, right? We try to pull together code or pull together small little modules. They are related to the same particular capability, like say passing HTTP requests. And if let's say if a config variable can be automatically tuned within the module, don't expose it. Don't expose it, which results in a simpler interface. Yep, like what we said, design somewhat general purpose modules. The purpose should be general. The interface should be general to support more use cases. However, at the same time, the module's functionality should also reflect your current needs to make it not too general, right? Like, so I think what this means in practical sense is when I'm thinking of running a function, first, like my first motivation to write a function is because of my specific needs, right? But when I write this function, I should ask myself, hey, is there any way I can make this function a bit more general to fulfill my downstream needs in the future, right? Something along those lines. Instead of just designing the function to fit my specific need at the current point in time, just ask myself, is it possible to make it more general? Yeah, so here are some questions to ask yourself when you are coding or like designing a piece of software. Like, what is the simplest interface that covers all my current needs? AKA, like, if modules can be merged with a simple interface, just do it. Second question would be, in how many situations will this method be used? If the method is only used once, it's a red flag that the module is too special purpose, and that we should make it more general by either combining it with other modules, or trying to make it more make it adaptable to more scenarios. Yeah, last question would be, is this software or is this API easy to use for my current needs? This is a sanity check to make sure that you didn't go too far to make the module generic without actually making it useful for what you want it to do at the current moment. Yeah, so with that, that's it for my video today. Thank you for watching. Hope you learned something. And if you like the video, please help me press the like button. If you have any questions or if you have any thoughts, please leave a comment. And yeah, thank you.